So if you did this, long L is equal to, and then you typed in a huge number, 3 trillion. A trillion has 9 zeros after it? No, billions have 9 zeros, so trillion would have 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. That would not compile. Let's prove that though. Of course, it's saying it's compiling. There. That is too large. Integer constant is too large. The reason why is that this is considered an integer literal. It's a series of numbers without a decimal point, so it's an integer literal. But it's too long to fit into the integer data type. If we went back and we found that slide, which indicated the largest value an integer can hold, that's way more than it. To indicate that it's a long value, or a long, then you tack on those L's to the end of it. You're still going to say go away? Never mind. Forget tacking on L's until they give us a good reason to. Okay, so if you're curious about how many bytes a variable takes up in memory, you can use size of to find out. So let's declare a few different variables. There's an integer, there's a long, here's a character, here's a string. No, I'm not going to use strings. Strings are special. Let's do C out, the size of the word int, followed by size of the int data type, ENDL. And it's giving me errors because I forgot to put using namespace up here. This was code left over from last week. There we go. Now let's do the same thing. Let's get the size of the long. Tell you what, let's declare two different types. We're going to make one called long, which is 2 L's. We're going to make one just called long, which is 1 L. We're going to print out the different sizes of both. Now let's print out the length of the character. And then let's do the length of an empty string. And to get the string character to print, I'm going to use escape sequences to indicate that I want to print out double quotes. And I do believe we've talked about escape sequences in quotes, right? Okay. So that's an empty string. Now let's print out the length of the word hello. Okay, so we're printing out these 6 things. Then it's going to do some junk down here. Why don't we just stop all that? I really wish I'd saved this program. So there's errors. I go to the error list. Main2 must return a value. Okay, my mistake. For some reason, and I haven't quite figured out why, the C+ Microsoft's compiler will allow you to get away without typing a return statement on main, even if main is supposed to be returning an int. But every other method, every other function that returns an int has to have a return statement. I haven't figured out why. What's so special about main that it lets you get away with that? I think that's an error on Microsoft's part. Okay. Here we go. So an int is 4 bytes long. A long is also 4 bytes long. A long is 8 bytes long. A character is 1 byte long. The length of this string with no data in it is 1. The length of this string with 5 characters in it is 6. And the reason why is that a string literal has an extra invisible character tacked onto the end, which is just the value 0. These are called null terminated strings. Otherwise, the compiler wouldn't know when that string ended in memory. So if we go and look and find string literal, eventually we should find something that shows a null or a 0. There we go, like the word hello. This is what the string looks like on the screen, but here's how it's stored in the program. The same letters followed by an escape sequence, which is just adds up to the number 0. So that's a 0 terminated string or null terminated string. That said, if we go back to our questions here, assuming the character data type uses 1 byte of memory, how much do the following literals use? Well, this is a character, so it is how many bytes long? 1. Here is a string. It's got 1 character in it, so how many bytes long is it? 2. Here we have something that's 5 characters long, so it is 6. And this one, it looks like it's more than 1 character, but it's really not. It's still enclosed in single quotes, so it's a single character. It's just an escape character. So that is 1 byte long. Write a program that uses the following character variables: first and last. Store your initials in these variables and then display them. So go ahead and fire up Visual Studio and write a program that has the room for 3 characters: first, middle, and last. Store your initials in those characters. You don't have to prompt the user for them, just hard code them, and then display them. So that's kind of a question for you. I'll do one of them, I guess, but you do the rest. File, new project. I guess I better close this solution. So I created an empty C++, so I go over to add source file, new item. My new file needs to be a C++ file. I'm just going to leave the name of it source.cpp. Really doesn't matter. What's our boilerplate that we keep using it over and over? What's the first line of it? Somebody has it memorized. I give you a hint. Starts with a pound sign. Bound include IOStream. Then, just for thoroughness, we're also going to include string. Then tack on using namespace std int main. If you're not a Mac user, you'll want to add this pause command at the end. Alright, I want 3 character variables. One called first, one called middle, and one called last. Now assign into the first variable your first initial with a single quotes around it, apostrophes, and do the same thing for the middle and for the last, and then print all 3 of them out with a cout statement. So at the bottom it will say cout first, middle, last, ENDL. Sure. Let me get rid of that. So here, fill in with setting your first, middle, and last initials. You don't have to add that comment, just put the code that does it. And you should have all this boilerplate memorized. You should be able to do it without me typing it in up here. If you also want to save it as a text file on your computer, that's also totally cool. So how do I assign my initial to it? Say that mine is J. I can't remember. Okay. What do I do? First is equal to single quote J. Then I do the second one. Middle is equal to G. And then last is equal to T. Now hopefully when I run it, it will print out JGT. And so it did. We all good there? We need more time. It's okay to need more time. Let me get ahead of you. And by the way, I know of at least 3 people doing Macs now, so y'all need to form a user group. And I'm trying to get a Mac from the department here so that I can help y'all specifically to use Xcode. Alrighty, next question. What is wrong with the following statement? What's wrong with this? Why would this be a syntax error? Yeah. And what header file must you use in order to use string objects? String. Yeah. Write a program that stores your name, address, and phone number in separate strings and then display those on screen. So just delete what you did here, or you can tack it on. I don't care what you do, but the definition of the problem is, come back please, right there. So this is letting you pick the names for your variables now. It's not dictating them to you. So don't use one-letter variable names. All right. Problem is, well, call this one main 2, by the way, and then this one main. And the reason why is it's only going to run one of them, and it's only going to run main. But the problem here is that these are actually strings, so change char to string. That'll work. Okay. So if you do using namespace, what you notice, you can leave off that std colon colon. Yeah. But you heard me say not to, so you're roughing it. Cool deal. Fix 'em. All y'all entering fake information just so I won't know where you think. Good idea. Security conscious. Okay, cool. That looks good. I can't see your screen. It's all right. Don't worry about it, as long as it's working. Cool. Okay. We're missing an opening and closing brace. You need a opening brace after the word main. Put on the same line or beginning of the next line. It automatically filled in a closing brace. Delete that closing brace. And go ahead and closing brace at the very bottom. Don't need a mark around X's on call. Okay. Now names and addresses and stuff like that are more than one character long, so you need to actually use the word string. So make this say string name. So you need semicolons. Put a semicolon after that too. Now you don't need to start a new program in order to do the address part. So let's just move this curly brace down here to the bottom. Do that part at the bottom. Now phone number and name and address, they're going to be more than one character long, so we can't use the word char anymore. So change these to string. Yeah, that's good. This is specified. Space. ENDL. Semicolon. So it's going to be string name, string address, string phone number. Remember, you cannot put spaces in variable names, so it can't be phone space number. It can only be phone number. Okay. So string name, string address, string phone number. My name is Sam Samuels. My address is 123 whatever street. And my address is, no wait, I've already done address. My phone number is 1555-1212. Now I need to print those out. C out my name, followed by an ENDL, C out my address, followed by an ENDL, and C out my phone number. Apparently, somewhere I'm lying. JGT's name initials name should not match Sam Samuels, but whatever. We could change that. First initial S, whatever. So Trent, make sure you have this line at the end of your program, so to pause, okay? And then run it, make sure it works. So character holds 1 byte of data in the C++ language. In other languages, a character will be 2 bytes long because it holds what's known as a Unicode value. And I've already explained, I think, that 1 byte can only hold up to 256 different values. Well, 256 different values is not enough to hold all the different letters in every language that you might want to use. So Unicode allows you to use more than 1 byte per character. And C++ also has data types that support that, but the default character type does not. Character literals have single quotes around them. A string literal is declared with double quotes, and there's an invisible null character at the very end of it. You could kind of prove that to yourself if you really wanted to. You're saying, why would I want to? Okay, let's go and write a little program. Tack this on right before your pause statement, and we're going to print out the the decimal values of all the characters in our name. Are we going to do this or not? Let me think to myself. Yeah, we'll do that. So define a character CH, define a counter called I, and set it equal to 0. And then let's put a while loop. While CH and what's the easiest way of doing this? Let's just make this a while true. I'm going to cheat. I'm going to use a while true with a break to bail out of the while. So I'm going to do CH is equal to my name, and I want to get that specific character out. I'm actually showing you arrays. I'm showing you something that we haven't learned about yet. If, okay, now let's print it out. Cout I followed by a space followed by CH followed by ENDL. And then let's add 1 to I. And if CH was equal to a \0, equal \0, then break. I'm not real satisfied with this. I'm not sure why I'm making us do this. Change the data type of CH from character to int, int. So when we run this, it will print out all the values of our name. My name is Sam Samuels. A capital S is an 83. We could look it up in the ASCII chart. A lowercase a is a 97. A lowercase m is a 109. A space is a 32. A capital S is again an 83. A lowercase a is again a 97, and so on. And we see that the string has all these characters in it ending up with a 0. The 0 tells the compiler that that's the end of the string literal. It'd be really neat if we printed both the number and then the letter and then the hexadecimal value. So we're going to change our C out to do that. Okay, that's our new version of the cout statement. I put these on different lines, which you don't have to do. You can put it all on one line. And now when I run it, I see my name, Sam Samuels. I see that the first character is an S, the second character is an A, the third character is an M, and so on. And we see that the counting of it actually starts with 0 rather than 1. Just like I said, computers always start counting with 0. And we'll see that the last character after the entire name is a null character. I'll just work before I add the changes. This string literal is also what's known as a character array. So a string literal is an array of characters. What is an array? It's just a list, a series of characters, which you can access individually by number. So since my name is Sam Samuels, the first character in it is an S, I can get a hold of that character with the number 0. And you access the elements of an array by using square braces. That's what this nomenclature is. This is saying get the specific character at the specific position. Our position starts at 0 because up here I said I is equal to 0. Then we add 1 to I, so we get the next character at that position, and the next character, and so on. Why do we spend so much time on this? Well, for one thing, it's building in the idea of what an array is. This represents an array. The first position in the array is always 0. So this is actually index value 0. This is index value 1, index value 2, index value 3, index value 4. And we will do arrays in a later chapter. But I want you to have that tucked away in your brain. So the C++ string class, we've been using it. It's a special data type that supports working with strings. To get it, you just do # include string. You assign them with the assignment operator, the single equal sign. Elsewhere, the book was calling it the assignment token, so no, that was a different text. Then you use double quotes around it, and you can display it with cout. Floating point data types. Float, double, and long double. A float is a 32-bit data type, and a long double, I believe, is a 64-bit data type. So floats are 4 bytes long, and long doubles are 8 bytes long. I will confirm that. I'm going to go back into my code and print out the size of a float, and then a double, and then a long double. So going back here, up at the very top of my program, I'm going to declare a float, a double, and then a long double. And even without assigning them any values, I could see out the size of the float, followed by the size of the double, followed by the size of the long double. And why did I make this uppercase? Just because I didn't want to make it a lowercase l, which looks like a 1. So when I run it now, it says 488. So again, we're seeing 2 different data types with the same length. A float is 4 bytes long, and an 8 is 8 bytes long. Now, how did this happen? It's just because the length of data types is not fixed. It's not dictated. You don't have to have floats being 4 bytes long. In earlier compilers, floats may have only been 2 bytes long, and then a double would have been double wide. It would have been 4 bytes long. Similarly, an int might not have been 4 bytes long. An int may have been just 1 byte long. And then, as computers age and they need to store larger numbers, not as they age, as technology progresses and you need to store larger numbers with the language, then they change the data types. So this is the current state of the art, and I believe it's true for both GCC, which you use on Linux, and for the Mac, and for Microsoft C, these values, that a float is a 4-byte number and a double is an 8-byte number. Just like an int is a 4-byte and a long int is an 8-byte.
So float, double, long double, they're all decimal, it's just the size of them are different?
Exactly. And these are actually identical. So we can throw long double out of our brain. So from now on, we're just going to use float and doubles. That's a 4-byte, that's an 8-byte data type, so it can hold much larger values. And then we have int I, which is 4 bytes, and we have longs, which are 8 bytes, or long int. And on an earlier slide, there was a maximum value that each one of those could hold. A char is 1 byte. So you can use a character to hold a number if you want. I could say ch is equal to 1, 2, 3. But it being only 1 byte long, it can't be larger than 255.
Max long double is 16 bytes.
Excuse me, I'm so sorry.
On Max it's 16 bytes on the long double.
Oh, really?
Yeah.
Cool. Okay, see, the compilers are different. If you're using a Mac, then a long double is 8 bytes on Microsoft, 16 bytes on Mac. How about long ints versus long ints?
The long int is 8.
And a long int is a...
8.
Okay, so they're both 8. Okay, so... Whereas a long int in Microsoft is 4, but a long int is 8. And you can leave off the word int when you're using these two. You could just say a long, or you could just say long. So on Apple, this is an 8-byte value, and so is this. You see what I mean? These things can change. Just know that a float is a smaller data type and a double is a larger data type. It's twice as big. And an int is a small data type and a long is one that's twice as big. That's good enough for us to know. Floating point numbers are signed. They're stored internally as a mantissa, which is a part before a float, an exponent, and then an exponent. So this is really stored inside as like 1.245 times 10 to the 1. So really that and that is all that's stored in there. That being the mantissa and that being the exponent. And in actuality, it's not doing base 10, it's doing base 2. Stored in a format similar to scientific notation. So single precision, you use the keyword float. It's 4 bytes long, meaning that it can hold a number between 3.4 to the negative 38 and 3.4 to the positive 38. So that's 3 followed by 38 zeros. A double holds twice as much. So it can be 1 followed by 308 zeros. Far larger value. That doesn't mean you can't use all those digits, unfortunately. You know. What do I mean by that? We have f here. F is equal to 1 divided by 3. Now let's print f out. We'll see how many decimal places it supports. C out f quote. Oh, come on. Now let's do that double. D is equal to 1 divided by 3. And C out D is equal to. We'll see that the double has a higher precision, but it's still limited. It's not, 1 over 3 is equal to 0.333. That goes on forever, conceptually. But there's a limit to what you can store into a computer's memory. So these things have limited precision. We will find out what their sizes are if it ran. It does not. I have to fix my compilation errors. Oh. That's just because I have other code existing in here. Alrighty. It said that f is equal to 0 and d is equal to 0. Great. Why is that? I printed out 1 divided by 3. I stored that in f, and it decided that that was 0. Can you guess why that would be? Because it's rounding down. If you take one integer and divide it by another one, it does integer math, which means it rounds it down. And what's 1 divided by 3? It's 0.3. But that's not an integer, so it rounds it down, and what's 0.3 rounded down? 0. That's why it printed 0. So let's change it. We're going to make it 1.0 divided by 3.0. Or even just 1.0 divided by 3. As long as one of them is a non-integer type, it'll actually do floating point math rather than integer math. Well, look at that. It printed out 6 types, 6 places for both f and d, which is not accurate. So let's go and Google up the precision of Microsoft C++ float and double. Or let's not. Let's skip that. Just know that one is more precise than the other. One has more digits to spare for precision. And if you've ever done chemistry or physics, you know what the idea of precision is. It's how many digits you can use to specify a value. One number this number, say you have D is equal to 0.33, that's 2 digits of precision. If you have D is equal to 0.333333, that's 6 digits of precision. And doubles have more precision than floats, and I can't tell you precisely which. Who knows, it may tell us in the very next slide. Nope. The Boole data type can either be a true or false. I know we've already talked about this. The way you declare Boole is just with the word B-O-O-L. Boolean. Boolean, I'm hungry is equal to false. If I'm hungry, see out, let's eat. So a Boolean can contain either true or false. You could either set it equal to a literal true or false, or you can set it equal to an expression. Like Boolean cold. Int temperature. Let's say the temperature is minus 100. And cold is equal to temperature less than 0. So if the temperature is less than 0, it's really cold. If cold, then print brr. Yeah, it's not going to print anything. We could put an else on here so it would print something. See out. No thanks, not hungry.
Now, is it the same where you just use an exclamation to make it a not?
Right, I could do, I could do if I'm not hungry,
So,
then I could reverse the logic. To make these things all fit on the same page, I'm going to take out the braces. So the expression between parentheses for an if statement needs to be a conditional statement, a conditional expression that will evaluate to true or false. Well, it can just be a Boolean variable that you've pre-decided elsewhere. Or you could put the expression right here. And that's how we did it the other day. We were doing things like this. If temperature is less than 0, see out cold, like that. You can do it that way, or you could store the result of that comparison and then use that variable. That's known also as setting a flag. We have a flag, a cold flag, and then we check the cold flag, and if it is cold, then we print out a message. Determining the size of a data type, you use size of. Variable assignments and initialization. Assignments are when you use the equal sign. Initialization is when you use the equal sign at the same time that you declared. So if I did this, int x, x is equal to 1, this is an assignment. This is a declaration. But if you do this, int y is equal to 2, we are declaring it and assigning at the same time. Which is known as initialization. The value has to be, the expression has to be on the right and the variable has to be on the left. You can't do 12 is equal to item. That's trying to copy the value of the item variable into a constant, which can't happen. So we would have to fix that by saying item is equal to 12. To initialize a variable means to assign it at the same type when you're defining it. This text is calling it defining it. Other books call it declare. If I use the word declare, I mean define, and vice versa. This variable is defined as being of type int. It can hold only integers. You can define multiple variables on the same line as long as they are all of the same type. Here we have a variable called length, one called width, and one called area. They are all declared on the same line. We could have done that with our name variables. We could have done this: string name, comma, address, comma, phone number. Char, first, comma, last, comma, middle. Whatever. I put them in a different order, and you can initialize them as you declare them. So I could do name is equal to Sam Samuels. Address, okay, it's going to get to be too large if I do this. So I'm going to undo that. But I'll do that example here. My first initial is a J. My last initial is a T. And my middle initial is a G. Is there any reason to prefer one over the other? Not really. Whatever makes your code look best and easiest to understand. If you're going to be assigning them as you create them, it's probably not a great idea to put them all in the same line, because this is kind of hard to read. And it'd be even worse if I filled in an entire name and an entire address and an entire phone number as I declared the variable. Here is a keyword that got introduced in the year 2011 called auto. If you use the auto keyword as your data type, it lets the compiler pick whether it's going to be an int or a float or a character or whatever. So if I choose wrong, the compiler is going to yell at me. So like if I choose character and I'm going to call this variable, I don't know, V for variable, and then I try to store a number in it, well, that was actually acceptable, a string into it, it's going to give me a compile error. But if I said, you know what, I don't really know what that is, I'm just going to call it an auto, it goes ahead and it works. And it's underlining that. Because I didn't initialize it. You have to initialize it in order for the auto keyword to work. I don't see any reason to do that. I see absolutely no reason to do that, because I know whether that's supposed to be a string or not when I'm typing it. It didn't save me a lot of space, you know. There. That's clear. But you can do that if you wanted to. You could do auto A is equal to 0, auto B is equal to 3.14159, and then the compiler would pick, oh, by the way, A is an int and B is a double. Excuse me, a float. Auto C is the word false, like that. Okay, then C is going to be chosen to be a type bool, and so on. Any reason to remember that? Like I said, I can't think of a reason to use that. Scope. Scope says where that variable can be accessed. And I know we've talked about this a little bit, like when I was doing those namespaces. Say I have a function called main, and I declare another function up here called silly. And all it does is also return 0. But it has a variable in it. X is equal to 3. If I call silly like this, just because I called it doesn't mean I can print out the value of X. Why? Because X is not declared in any place that this can reach. X is declared up here. It's in a different, quote, scope. It's in the body of the silly function. It's a local variable that's part of the silly function, so it is not in scope here. Just like if you have a hunting rifle. If the deer's not in the scope, you're not going to hit it. How would we fix that? Well, we could make it a global variable. we would move it outside of both of those functions. Whatever, you know. So here we have a global variable. Global variables are always in scope for the entire piece of code. Local variables are only in scope inside the function in which they are declared. So if we do this, y is equal to int y is equal to 4, that's a local variable, meaning that I can't come down here and then print out y. Okay, based on what I just said, why is this statement here giving me a syntax error when this one doesn't, even though they look almost the same? Why is that y a syntax error? Yeah, it's out of scope. It's not in scope for this function. Y is local to this function. Local variables are only in scope inside the function in which they are defined. Or even more specifically, in the pair of braces in which they are defined. And what do I mean by that? If I go along and I do this, if x is equal to 3, do something, whatever it's going to be, and then I declare another variable, woogly. Now that I have that variable woogly, I can't do this. Why? Because woogly is not in scope. Woogly is a local variable that's only in scope for the body of this if statement. It's only in scope between these two braces. So when I get down in here, it's no longer in scope. If I wanted this cout to work, I'd better either move it into these braces, or I'd better define this variable beforehand. If I did this, int woogly is equal to 0, and then changed it equal to 4, that works, because woogly is defined here. It's in the same level as this one. So now woogly can be printed out. But that certainly did not work when woogly was local only to this if block here. So the scope of a variable is a part of the program in which it can be accessed. A variable cannot be used before it's defined, and it cannot be used if it's defined in some other part of the program that is not local in scope to where you're trying to access it. Here we go, variable out of scope error. Here we're trying to print the value, but we haven't even created the value yet. Here's the line cout value, but the next line is int value equals 100. This variable is not defined yet. Arithmetic operators. There's 3 kinds of arithmetic operators. There's the unary operator, which takes one operand. The operand is the variable or the constant next to the operator. Well, there's really only one unary mathematical operator, which is the minus sign. That's how you indicate a negative number. If you say x is equal to -3, the negative sign is called the unary operator. Do you really think of it in those terms? Not really, but that's what it is. A binary operator is one that takes 2 operands, and there's several of those. There's addition, subtraction, multiplication, division, and a modulus. Those are several binary operators, and in this case binary doesn't mean zeros and ones, it means that it takes 2 operands. So you could do this, cout 3 times 4. This is a binary operator because it's got 2 operands. And then there's the ternary operator, which looks like this, and it's called ternary because it's got 3 parts. And I'm not going to even tell you what this does yet, but it's got that operand, that operand, that operand. We'll talk about that later. Okay, so the arithmetic operators, have we talked about modulus yet? This will be the last thing we cover today. We know what addition does. We know what subtraction does. We know what multiplication does, and we know what division does. Although, if we're doing integers, then it rounds down, which is a slightly unexpected side effect. But if we do this, cout 4 times 3, what is that going to print? That's going to print 12. How about 4 plus 3? That's a 7. Yeah, these are not trick questions, except when we get to divided by. 4 subtracting 3, that's 1. And 4 divided by 3 is actually also equal to 1 because it's equal to 1.333 rounded down. Why is it rounded down? Because both of these are ints, so it did integer math, and integer math results in a whole number. If I didn't want these to be whole numbers, one of them at least should be, a floating point number. And then lastly, there's modulus. Well, when I divided 4 by 3 and I got 1, there was a quantity left over. What was the remainder? 4 divided by 3 equaled 1 with a remainder of 1. So 4 modulus 3. Modulus means remainder. So this also prints out 1. So what is 4 modulus 2 equal to? Well, 2 divides evenly into 4, right? So there's no remainder. So that's 0. What is 5 modulus 2? Well, 2 goes into 5 how many times? 2 with a remainder of 1. So that's 1. How about 7 modulus 3? 3 goes into 7 how many times? Well, 2 times with a remainder of 1. How about 100 with a 99 with a modulus of 10? 10 goes into 99 how many times? With a remainder of, instead of making that 99, I'm going to make that 95. Okay, and then now what's the modulus? 5. Is that making sense to everybody? Good deal. So modulus just means remainder. All right. If anybody missed signing in, you want to come in and sign so you get credit for being here, or I could just bring it around.
Function. All you're wanting is a screenshot of the final, right? You don't want us to upload the actual chaos.
Well, you could, but really a screenshot proves that you got it to work.
Screenshot. Okay.
Yeah, it's cool.
And
Yeah.
I saw your change the name today. Well, when I did it, I just named it Chaos 1 and Chaos.
Good.
Okay.
Because I've had people erase the first chaos function and then send me a text saying,
I got to that
yeah.
point, I was like, well, that won't work. I was like,
You're going, I don't want to do that.
Yeah.
Okay, good job. question. Do I have a homework file out there?
Yes.
Just where at?
There's no Dropbox for it, but you did add documentation somewhere. Let me find it.
Yeah, if there's no Dropbox for it, the clock's not ticking on it, but I'd be real curious as to where you spotted it.
That's Unit 1. Unit 2, April 6th, in-class flowchart to code.
Ah, well, that's Unit 2. So, yeah, don't do anything from that folder yet.
Too late.
Okay, cool.
I mean, it's not.
You're already familiar with this
Quite
stuff to a fair degree, so yeah, there's no.
Well, I'm a programmer in the Air Force.
Right.
So, I mean, what we took in tech school was pretty bare bones, but the logic's the logic's the logic.
Yeah. And it's true that we could go faster, but if I go faster, then some people will struggle to keep up. So I apologize for that.
It's okay. I've been trying to I've been playing around with user input validation, which is kind of a bitch in C++.
Yeah, it is. Absolutely.
I currently found a method that seems to work, but I don't fully understand it. So I'm going to keep using it, and hopefully we'll get the hang of it. It's definitely using code I found on the internet. I'm not going to pretend that it's mine, but I'm not going to not use it either because it works.
Yeah.
So I don't know how that works with your class and school and all that, but I'm definitely going to use it. It works too well to not use.
Right. Well, I'd like to see it actually.
It's using string streams.
Oh, okay. Cool.
So it's inputting into a string stream, and if it inputs correctly, then it breaks out of the loop.
Yeah. That would be how to do it. That's cool.
Yeah. I don't fully understand what string streams do or why that works, but I will eventually figure that out. I should save this so that I don't have to have access to it.
Hello.
In this homework, I logged in and download this file and set up on my laptop. So do I need to submit anything for you?
As long as you got it running, just submit me a Word doc or a text file saying that you did it.
Like,
Just anything. Just say, I installed Visual Studio. Or you can make a hello world and then give me the .cpp file.
okay,
Okay.
thank you.
Sure.
Okay. Thank you, sir.
Sure thing. See you Thursday.
Have a good week.
Oh, you too.